Hello. Center up. Okay. Gonna be a little bit of a weird one this time because where we left off was we have concatenation working, but there are some holes right now. So we're calling testing1 and we're passing it capital out, which is this snippet right here. We are calling write and we're passing it std concat_arg underscore file number. So this is turning into std out underscore file number, which is great. So this doesn't work. So let's go to that one and just see what it does. So this one, I should be able to replace arg with rit, and it should stick it in there, and that should just work. But apparently, according to my to-do, this doesn't work. Yes. So I need to figure out why that is. So what is the error here? W was not declared. So it looks like it's just not replacing this. Yeah, so you can see here. This is what that call is turning into. And in fact, we don't even have the E on the other end. Interesting. So why? Print out the tree. Here's that snippet. So that's incorrect, as you can see here. The name of this function call is just W when it should be... Okay, so first, here's another place where we're calling concat. I should call out this as a concat node when I print. So let's do that really quick. So when I construct node name, let's let's add a new parameter to this. Let's call it, I don't know, backend. Yes, I have a to-do here for this. We probably want to maintain concat node or concat etc. for nodes when printing the AST. So we can remove this to-do because that's what we're doing right now. Backend just preserves things like concat in names for when printing the AST, for example. Not used for codegen. We'll say this is not meant for codegen. Whoa. Okay. So we're calling construct identifier string. So we'll pass back into that struct identifier string. And I guess we'll say false here, even though I think we're only using that. Yeah, we're actually not calling that on its own. So we'll just say this is always required here. Right, so if it has a node with it, we'll say if cur node flags, let's see, what did we call this? If it has this concat flag on it, then here's what we'll do. We'll say result plus equals this, and we'll say on the other end this. Whew. Okay. Okay. And that might be all we have to do. So for now, this shouldn't affect anything. Right? Correct. Wait. That did fix this. Why? Because backend, we're not checking for backend, so we're doing it all the time. So now we're not doing it, which we don't want to do it. Well, is CodeGen ever going to be spitting them out verbatim like that? I don't think they will. They're always going to be constructing it. Well, whatever. Just to be safe, we'll lock it behind that just in case. So, here we will say true, true, true. Okay. Great. So there we go. We are now printing that out. So notice how we're just not doing anything here at all. It's just stopping. And I think that's because in decl we are properly grabbing this whole identifier or this whole name. I'm guessing we don't do that in function call names, maybe? I'm gonna center up my camera here. It's a little off. It's bugging me. Okay. So let's go see that. So in parser, let's go to parse function call. Or no, this is gonna be an expression leaf. No, parse expression call. Parse as function call. So we create a node. The expression is the expression. Oh, right. They don't have an identifier, they have an expression. So function call, they don't have a name like an identifier like the other ones, they have what's called expression. So I'm guessing something weird is happening there. Let's go to CodeGen and do, what is this called? It's called do concatenation. Yeah, so here's what we have in concatenation. Anything that has an identifier, right? identifier explicitly, special cases, grab their expressions identifier. So so these special cases are like so we'll say expression holds the identifier. We call get identifier, get node identifier. So that's what this was doing. So we are in fact grabbing the whole thing. So that tells me that we're actually just, it's before this step even. We're not even grabbing the entire thing. Let's go into the parser and go to parse as function call. Let's just break here and just see what we get. The left is a decl ref whose identifier is W, and it does have a next pointer, whose type is a decl ref. Arg. Okay. So it is right on the AST. That is correct. Left is an expression that we're going to parse as a function call. Right? And the expression here is a decl ref whose identifier is W with a next, which is arg, with a next, which is E, and no next. So that is right. That's set up correctly. So next here is a parent open, right? So we knew that. Parse call params. That should be fine. Here's the result, the function call. It has no children. After we parse the params, it has a decl ref, a string, and an int. Decl ref, string, int. So that worked. Okay. So what do we do with it? Next is a semicolon. So we just return left. That's it. That's our expression. So that just worked. What are we in right now? We are in do parse. Okay. And we add it. Okay, so that is working. That just worked. So I know it's right on the tree. So let's go back here. Print AST. Let's go to function call. Maybe I didn't update this correctly. Construct node name. Let's break there. CodeGen 387. Can I jump to a line here? Yes. Let's go here. Okay, let's see what the node string is. It's just W, so we know that's wrong. Let's see why it's wrong. Node type is a function call, so we're going to get node as string, but we're going to do it on its expression. Get node as string. Oh. We're not calling construct node name. we're calling get node as string. Hold on a sec. So here we return the identifier, here we turn... No, this needs to be construct node name. That work? Where are we? Okay, that still didn't work, but I think that's right. I think that's right. So let's go again. Construct node name. It's a function call, so we're going to do it on its expression. We go into it. So let's look at the node here. It's that decl ref whose identifier should be... where are we? Decl ref. Oh, it doesn't have a next. We lost the next somewhere. We definitely saw it when we parsed it. So that's interesting. Let's see what's going on. So at some point between parsing and code gen, we are losing that. So left is a function call whose expression is, this is the decl ref we were looking at before. Here, it's set up correctly. So when do we lose that? There's the expression. Boom, boom. Add child node to root, which is the compound statement. The expression, which is a function call. And this function call has an expression inside of it, which is this. Decl ref. There it is. Okay, so... yeah, we just added that to the tree. So why... so if we look at the root now, all of its children, there's that function call. Info, function call. There's the expression. Info. There it is. It's got next. It's got all of its stuff. So let's go forward and jump to code gen here. And now we're looking at node. Here's that function call. Info, function call. There's the expression. And it's 0. We're losing that somewhere. Oh, wait a minute. Okay, hold on. This might be a little confusing. This might be because that initial function call we parsed is up here, and it's got all of its stuff. This second function call we're trying to print might be the one that we expanded here. It might, I don't think it's this snippet up here. It's this, well no, it is. It has to be, because this one's also missing. Okay, hold on. This is now confusing. Let's go to the parser, and all the way at the end here, when we're done with do parse, let's just look at what we got. AST, there's a root node. Its children is a source file. It's only got one source file. Its children are an include, 3 snippets, and main. We're looking at the first snippet, so this one here. It's got a param and a compound statement. the compound statement. There's our function call. Is this set up properly? Function call, expression. Boom. Yes, that's fine. We parsed it properly. So that's fine. Okay, so that we know that's working, right? So we parse the lexer. Boom, 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 boom. Okay, and now we're gonna go to a post pass on it, and then we run the metaprograms. So what I'm curious about now is if we go back to CodeGen here, and we are printing, so let's get there. We're printing this. Let's look at where we first started. Here's the parser, here's the root node. Children, source file, children. There's all our stuff, snippet, children, compound statement. There's our function call. Expression. Oh. It's gone by the time we get here. But this should be the same thing. Can I do this? Can I do root node? So there's that. And then can I do global parser? Wait, global parser AST is what I really want. Okay, these are pointing to the same thing. So at some point, how did our global parsers AST get? Here's our global parser, here's the AST. Same thing, we're gonna go down to the function call. Wait, where are we? Function call. Here's its expression. Okay. We lost that at some point. Don't know where or how. So let's do this. Let's say, let's watch. Let's go to global parser. Now we have global parser. So we're gonna say global parser AST children. Actually, can I do it this way? I'm gonna be sad if this doesn't let me do this. Children. Wait, this is the function call. Its expression is a decl ref. Okay, can I, like, I want to watch this thing. Copy as expression. Oh, thanks. Oh, and it doesn't know that it's a pointer. Oh god, this is awful. AST children. Oh god, this is awful. Thanks, Visual Studio. You make this very easy. Info, boom, expression, info, boom, boom. Yeah? And of course you can't wrap or do anything. All right, whatever. Okay. So there it is. There's our next. W, and then an expression. Okay. W, the concat, E. It's there. We see it. After we do the post pass, does this go away? Is that why? It's not, we might be stepping over it there. We are. At some point in the post pass, we're just stomping over it. Hey Yoshi boy, it's going okay. How's it going with you? Thanks for following. Just debugging some annoying metaprogramming stuff. Okay, let's see why. Let's see why. Why we're stomping over this. Let's go to the post pass. Or you know what? Let's just run this again and step into this. At what point are we losing this? This next pointer, or all this data really gets stomped. Quick shell. I don't know if I know what quick shell is. Oh, okay, cool. That actually looks really nice. At a high level, so I'm building I have built a parser for what started out as a C parser, but has since kind of ballooned into kind of my own mini language here, and it supports metaprogramming, so it will give you access to the syntax tree, and you can modify it via a metaprogram. And so like right now, I want you to be able to concat stuff together. These are like fancy macros, basically. I want you to be able to concat stuff. And to support that, it's kind of required a really big refactor of the way identifiers work. So we're just in the middle of debugging that right now. So like right now, this here, where I concatenate this argument, you can see here on the AST, it shows up properly. That's actually working. This one though, I'm trying to concatenate this function call, like this name. And it is not showing up properly. I'm just getting the first one, like the W here. So that's what we're doing right now, is figuring out why this data structure over here is the identifier. So you can see the W followed by a decl ref followed by the E. That should be this, right? The W followed by a decl ref followed by the E. But then after somewhere in this function, this data is getting stomped. So we're losing that somewhere. So it's not there. Not there. There it is. So it's in replace snippet calls is where we're losing that. So let's see why. If you're curious about like the overall system and how that works, in the description of my channel, like just below the video here, I link out to a video I made kind of going over the whole system and like the metaprogramming stuff. So if you're curious at some point, you can give that a watch to kind of get an overview of how the system works. And that video is a little old at this point. I will be making another one that kind of gives an update, but okay. So I want to see when we stomp over this. I'm assuming it's Oh. Oh, did I leave that? I think I left that unfinished. Create node copy. Am I not copying? I'm not properly copying over the identifier. That's why. That's definitely why. This function is not handling the copy correctly. So if I want a copy of a given node, I copy all of its normal stuff, and then for each child node, I create a copy of those. Yeah. Then I grab my okay, let's see where that's going wrong. Okay, at least this is a known. I kind of knew that function wasn't doing what it was supposed to be doing, so that's fine. Okay, so our source node is this whole snippet. Oh, weird. So it makes sense that the copy of the snippet is breaking, but this is also breaking the source, which should never happen. So, because here's our snippet, and our compound statement. It's a function call. There's the, no, not this. We want the info function call. Here we go. This decl ref. So yeah, right here, this function screws this up. We break this. So, okay, so that's all fine, I think. For each one, we copy. Yeah, it's here. We break it here. I know we do. Ooh. Oh, no, because that calls it recursively. Okay. Oh boy. So let's break here. So for each child, right? This child is the param. I don't think we care about that. See? I don't think we care about that. Wait, how do I go up? There. So we don't care about that. The compound statement we do care about, because it has a function call, so we care about that. So we don't care about any of these individually, the children. Those I think are being copied fine. We don't care about this. Let's pause this. Breakpoint. Okay, so we're still in the function call. We still have this. This is where we are breaking. So our source identifier and our result identifier. Oh, of course, they're the same thing. They're the same thing. Because we just copied it. Okay. These are the same location. I think what this really has to be is so can I do result ident equals this? No, because that's also now pointing to the same thing. Okay, hold on. This thing So this is a blank node. When I copy the info over, I grab all of it wholesale. I need to clear identifier of result is what I need to do. Which means I need a, get node identifier. I need a clear identifier. Clear node identifier. So I need to empty this out. So, I'm gonna have to switch on this just like I did before. I don't want this to be in the same place though. I want a pointer. Let's do this. Let's create another one of these. And we're gonna get a pointer here. This is gonna be a pointer to the pointer. Get node identifier pointer. So we're gonna return the address of Can I do that? I don't know if I can do that. Oh, I just don't want to duplicate this logic or this switch statement. I mean, I guess I kind of have to. So, note, keep this switch in sync with get node identifier. So I'll remove all this and just know when I go do the one below it, I'll just know that I have to bring these over. So this doesn't return anything, and we're just gonna say if it's these, its identifier is empty. Same with this. Its identifier is empty. With this, its expression is empty. And in this case, it's a pointer, so it's nothing. And in this case, it's empty. Okay. We don't return. Okay. We are segfaulting. That's not great. So let's just step through this now and see where we're at. So, replace the snippet calls. Create a copy. Okay. This is the snippet. This thing's identifier is... It's just a name, so this doesn't matter yet. That won't do anything. Children. This is a param. I don't think we care about this either, because this is a variable whose identifier is already nothing. Well, it's arg, but I don't think we do anything with that. Okay, we do clear it. But then does this now work? Yes, that copies it back over. That's exactly what we wanted it to do. So next one is the wait. The compound statement. We'll do that. The function call. Great. So we will do that. Okay, create a copy of the function call. Here's the result. Boom, 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 boom. This should now have the expression, and it should have a decl ref with a next. There you go. We clear it. Boom. So it just lost its expression. Everything else should still be there. Line number, all that stuff is still there. Wait a minute. Yes. Okay. But we did lose the expression, which is fine. Set the parent up, and then for each child node, we're going to create a copy. So the child in this case, let's close this, is the decl ref, which... Oh, these are its children. We don't care about that right now. Those are the parameters and stuff we want here. Oh. Aha, okay. Get node identifier is now not going to work because it no longer has one. Right, because we just cleared it. So in this case, we don't care about create node copy. We will not have a result. We just cleared the result. We just want to know we have a source. Still sec faulting, so we're getting there though, I think. Okay. This is the snippet. Not the param. Let's do this. Compound statement, boom. Function call, boom. Okay. Don't care about these. Okay, that still broke. Let's go here. Let's drop this and drop this. And let's go back to where were we? Create node copy. Set this to read only. Create node copy. Okay, let's break here. And we're going to do this when we're on the function call. Here we go. So this, I think, breaks. Yes. Let's figure out why. Function call. Okay. Get node identifier of result. And result, let's just go into it. Node is a function call whose type is a function call. Okay. Get node identifier of its expression. Right? Which its expression is... Right. Right. It doesn't have one. Yes, it doesn't have one. I need this to be the pointer to it. That's what I was saying before. This has to be the pointer to it. I don't know if I can do that though. I just don't know. because in that case we don't have to do this. We don't have to clear it in that case. It's not necessary. Because I want a pointer to the data structure there. Let's just see it. Let's just see what happens. If I copy this and we say get node identifier pointer, given the node, I want to return the address of the address. I don't think I can just do this. I don't think this works. Just does that even compile? I probably have to, if I'm going to do this, do this. I don't think this is even going to work though. Yeah, that's what I thought. Okay. Okay, hold on. How about this? Let's remove, if this has an identifier, we're going to copy the identifier list from source to result. That's what we're going to do. So we're going to say copy identifier list, and what it's going to do is, instead of identify, we're not going to work at the identifier level, we're going to work at the node level. And we're going to say that if we're calling this, let's just assert that we have a source and assert that we have a result or a dest. Okay. And then let's get rid of this, and we're going to say, or no, we're going to say get its identifier node equals get node identifier source while source identifier right, okay. So assert source identifier. So as long as we know we have one of those, we're going to do this. Dest. Oh boy. Because this isn't just an identifier. This is an expression. So wait, so why isn't that working? Let's go back. Hold on. So right now, we're back to this. We're creating a copy of the function call, which means we copy this whole thing. We just have to set expression. We need a copy of the expression. So this is what I'm worried about. We have some things on here, on every node, inside of this info struct, that need deep copied, such as this expression here. But that's going to depend on the type of node it is. That's really what the problem is. And of course these identifiers need deep copied as well, which is what this is supposed to be doing. So info is going to be have to be handled separately. I hate to have to do this, but I feel like we have to, because now this info can have stuff that needs deep copied, and we currently just don't support that. We can't just move that over. Which means this can be hoisted out into here. This will be part of the deep copy. Okay, so let's just start writing this. Assert that source type and desc type are the same, and then we will just switch on the type. Okay. And we're gonna say, man, if it's one of these, we do one thing. If it's one of these, we do a different thing. If it's one of these, we do a different thing. Do I have a meta union? I don't. I don't know if that even makes sense. So this will be its own thing. These will be its own thing. Type def. Expression type. Expression type def. Oh, it's a decl. Duh. These, and actually let's remove 1, 2, 3, boom. That. Okay. Decl ref. Keyword. Cast. A literal. Is it just literal? Okay, it's just all these. Ah. Okay. All right. Literal info. Okay. All of these. I have so many of these dispatches for these that it's really bad. It's annoying. It's like upkeep that is very perilous, and I really don't like it. I really don't like it. AST pre-proc include. Okay, and we've got include param define body undef if snippet depend. Param define body undef if this is just a snippet. Depend and expression. Okay. Whew. So we are going to do a macro, and we're going to say search for // boom boom case boom we do all these, and then for each chunk we are going to say boom boom boom. I could have done that whole thing with the macro. In fact, I'm going to, because oh, nope. Can't do that even. Not for these long boys. Okay. Jesus. All right. Now to deep copy these node infos, if you are a I guess I didn't do these. I probably should. Root and source file. So if you're a root node, all we have to do is say source dest is it root? Is that just all it is? Root info? No, just root dot. Okay. Just do these one at a time. Base path equals source root base path. Source file is just source file, and it's just path. For variables, it is a lot of things. Let's just copy all of them. Okay. So here's where we're going to want a copy identifier list. So we're going to want that. Copy identifier list from source. Source info. Oh, these are infos. source info decl variable dot identifier, and we're copying it to the dests identifier. The type is just a string, so we can just do that. We can say source, or we'll say dest equals source that. The type node, that we can just copy. Pointer depth and reference depth. We can also just copy those. Dest equals source. Dest equals source. Flags we can copy. Actually, okay. Instead of doing this dumb way, let's just copy the info over. No matter what. Type specific procedures. Shallow copy wholesale. Then perform type specific procedures. This is what we'll do. Dest info equals source info. Yes. And then, so we don't have to do this. We can just remove these. Variables. We do the identifier list. We don't have to do any stupid single copies. The array sizes are an array, what are these? It's an array of nodes. It's an array of nodes, or a pointer to an array of nodes. I forget what that is. So any of types is just a dynamic string. We can just copy that. That's fine. Dest any of types. Let's see, dynamic string, copy D string. We can just say copy D string. No. I want to allocate D string. Global parser arena. And the initial value is going to be source. We're going to say dest any of types equals allocate D string source info decl variable any of types. Okay. So I gotta remember what this thing is, and I don't. I'm gonna have to go into the parser, array sizes, parse array params. Oh, it's an array of a bunch of nodes, because you don't know how many dimensions it'll be, so it's a I have to allocate an array of those. And each one of those is itself an expression that I'm parsing. So right. So this thing, first I'm going to say so first dest info decl variable. So we're going to say this identifier array sizes any of types. So array sizes is this thing. This is the global parser, and the dimensions are the sources array dimensions. Well, I mean, no, it can be mine. We already copied that over, so. And then for each of those, this thing we're going to deep copy those. We're going to say dest array sizes size index. We're going to create node copy. Source. This is going to be that. Just make a copy of it. Yeah? Everyone okay with that? Whew. Next one. Name is fine. Identifiers. So we gotta copy the identifier over. We'll do this. Copy the identifier list. This is a function. This is a function. And we also do the return type. Return type identifier. And the return type node, I think, is fine to just copy over. Okay. Once again, this one does an identifier. Okay. And then we'll also do the generated from me, which we can just loop over. Info decl struct generated from me. Index. Grab this thing. This is num generated from me. Index equals create node copy of. Well, actually, I don't think we have to do that. This is if you're copying a struct template. Well, you might do it in the future. I don't know. Who knows what I want to use this for, where it might go. We might as well be thorough. Gonna create a copy of the source. Might as well. Union. Super easy. It's just the identifier. Enum. It's just the identifier. Oh, I want to remember, I'm going to make a note for myself to rename bit fields to flags. I remember thinking about that the other night, and bit field means a very specific thing. These are definitely more accurate to call flags. Okay. Great. Nope, we're not done yet. 2 identifiers. That's all we need there. For type def. Base type identifier. So this is type def. Base type. Function call. Alright, this one's going to be a little trickier. I forgot assignment statement, but it doesn't matter because that's a shallow copy. Function call. I have to copy the expression. So expression dest info. This is a lot of just busy work, but it's going to be frustrating because in the future this is going to have to be maintained. I don't like having so many copies of these big dispatching switch statements, but it is what it is. Info expr function call expression create node copy, and this will be doing a deep copy of yeah, this will be doing a deep copy of the identifier too. So create node copy of the same thing, but from the source. And that's it. And then decl ref, this one's also got an expression, or I mean an identifier. Expr decl ref. Decl node. If there's literally the type, if I'm making a copy of a decl ref, should it be pointing to the same thing? Maybe? Well, I guess if I'm making a copy of a decl ref, I'm going to be updating it almost immediately. Man. I don't actually know. I don't know. I feel like I can just leave it as a copy, and if it needs to get overridden, it will. But I worry that that logic will not do it if it already has a value in it. Because if you're making a copy of something with a decl ref... Alright, I'll just leave it for now. It'll just copy the node over. I'll put it to do in here. decl node. Because I don't know. Keyword is an identifier. Most of these are going to be identifiers. Decl ref, keyword, expr keyword. Yes. Cast is identifier as well. Decl ref, cast. Literal should be easy. Because literals, I think, besides dynamic string, can just all be shallow copied. But so only if it's a string. String concat. Yeah, I think if it's only this, do we actually care? And we're gonna say only strings need be copied. So dest info literal dot string equals allocate dstring global parser arena, and it's just going to be the sources string. Okay, all of these simple copy, simple copy, simple copy, simple copy, simple copy, simple copy, simple copy. Those will eventually need to be identifiers, but body needs copied. Undefined doesn't. Preproc if does. I don't think we're doing preprocs actually at all. I don't think we're going to be copying those. That will eventually need an identifier. Okay, nothing else does. Okay, so I'm going to put don't forget to update, what function is this? Copy node info. Okay. So now when we create a node copy, we are going to do all that. And where info should be, we're going to say copy node info from the source to the result. Great. Is that it? This is going to break horribly because we just did a lot of things. Oh, we don't have a default case in here. Oops. 1043. That's just a typo. Way less errors than I was expecting, which is nice. But that was also a lot of like just rote copy paste. Any of types. It's a dynamic string pointer. Oh, it's an array of dynamic strings. Oh. Okay. Allocate. No, this is push array. Global parser arena. Dest info, decl variable, any num, any of types, and then we have to loop over and copy all of them. So for index equals 0, index is less than this. Nope. Okay. We're going to allocate. This thing. Any of types at index is equal to this thing, any of types at index. Okay. Push array. What did I forget to do? Type our dynamic strings. Okay. 1105. Decl type def. Type def. What did I do? Oh, alias identifier is what this is called. Okay. 1120. Decl ref. This is decl identifier. 1140. This. Oh, is it value? Value. Literal value dot string. Okay, did that actually all just pretty much work? Well, we're segfaulting, but if I don't copy the node info, or actually let's just not do the deep copy part and see if we are segfaulting still. Let's just not do this part. Ah. Okay, so somewhere in the deep copy we are segfaulting. Not great. Let's see which one it is. So let's write output, or you know what? Let's write output. What did I call these? Parser node type strings of source type. Decl, it's on a decl param? Okay. Well, let's just step through this now that we know which one it is. Copy node info. It's one of these. Let's remove this and this. Source is null, so where were we? Create node copy, and we were at decl param. That's a little concerning. This decl param has no parent. Oh, because we haven't copied it yet. Never mind. Okay, we just haven't copied it yet. Variable. This is care. What's the name? Args. And it's a pointer. So this is this here. We're trying to copy this. It's got a pointer. Its type is care. Its name is args. And it should have an array depth of 1, right? And it has no array sizes. Oh, that's probably why. Because I don't think I'm checking for... yeah, if right, we only do this stuff if the source has an array sizes at all. If source If it doesn't, we don't have to do anything there. Right? Yeah. Or really, you know, if we do, right? Because we've already copied that part. So let's go back in here. Okay. Oh, what'd I do? Ah, what'd I do? Stop. Okay. Boom, boom, boom. Okay. So let's go back up here. Result is a param. Decl param info. Boom. So array size is 0, which is good. No. Star array sizes needs to be 0. And actually, this needs to be source. Okay, geez. Okay. You know what? Let's get rid of this breakpoint. We don't need it. Let's just see where we break. Oh, okay. We need to get at array sizes and dereference that. No? Source, info, decl variable. Okay. If this and that. There we go. We compiled. And we have our deep copy. It is working. What an arduous journey to get there. But we got it. We got it. So, that's good. So because of that, do we now work? Oh, we do work. We have an output message. that just worked. We have an output message now. Oh shit! What did I just close? Damn it! I closed something I shouldn't. Parser. Okay, that line number's still broken, so I want to make sure I fix that. But there we go. So this write is coming from this call. We're calling testing 0, which is a snippet, and we're just passing RIT. And RIT is getting concatenated in between this W and this E to create the full thing. So if I replaced this with like hello, it's gonna be like my function call that I'm calling now is W hello E, and it's like I don't know what that is, but it's because it tried to replace it. Great, that's working now. Get rid of that to do. Great. Now what about testing 2? Does that work? No, was not declared. So this doesn't work. Regular argument passing is busted. Oh, because this isn't even... Did I break just regular arguments as well? I did. Okay, so regular arguments are not working. Say these don't work. This will be out. arg. Okay. So let's do those next and figure out why those aren't working. I will be right back though. I'm going to get a water. That's really good progress though. Getting this one knocked out is great. The fact that that's working now. It was a pain, but we got there, so I'm okay with that. Okay, I'll be right back. Okay, I am back. Okay. So let's close this and get back to the parser here. So why is normal function calls broken? Let's fix that first. Let's forget about number 2 and just try this. Update function call if macro. Let's go there first. Update function call if macro. Oh. Why do we think that's a macro? That shouldn't be happening. Why do we think that's a macro? We should not be doing that. I mean, this logic's wrong anyway, but we should not even be getting here. We should not be thinking this is a macro. Oh. Oh. This is a checking if it is one. Okay. This logic is just wrong. So it needs to look more like this. In fact, this whole thing just needs to look like this. So let's just do this. Let's copy all this boilerplate. And then for each preproc define, if the name is what we found, then this thing is a function, is a macro call, and the decl. Okay, I think that's it. Function call does not exist here. Right. AST query. Update function call if macro. Why are we passing two things? I don't need to be passing the AST in. Why are we doing that? Well, hold on. Okay, I don't know why I'm doing that. Okay. This needs to look like this, honestly. And honestly, let's just consolidate these two things. Update function calls to macros or snippets. How about that? And we'll take this whole thing. For each function call, we'll do if we do that, otherwise if we do this. Okay. Now, if it's a snippet, we do that. If it's this, we do this. Okay. 718. Right, we no longer have query here. This is function call. Okay, and then 2173. Instead of both of these, we will do update function calls to macros or snippets. Great. Still not working though. So this is oh, okay. Okay. So here's the snippet up here. This is testing 3. So it's this one here. We have two parameters, text and size. And here's the body. We call write with standard out file number, we pass it text and size. The way a snippet works is when we call it down here, this is our snippet call technically, but at this point we've already replaced it. This body of this snippet gets copied and wholesale replaces this. So that's why starting here, a call to write with 3 parameters, a call to write with 3 parameters. We just pasted those in. But what we didn't do when we did that copy is replace these properly with what we originally passed it in the function call that was here. So that is broken. Why is it broken? I don't know. I don't know. But that's at least what's happening there. So let's go to so here's where we turn it into a snippet call, and once we match that, once we know we're a snippet call, we want to make sure that we find the one that has the right number of parameters. And if we do, if we find one where we're, okay, we found one that could potentially be what we're calling, we link it up. So, snippet call. Okay, before we do that, actually, let me look at this line number thing and get it fixed. Let me go back to this other one that we got working. This here. This line number is wrong. And it is the... hi, Chandru. What problems do you solve with metaprogramming? At the moment, nothing, because I'm still working on the parser and the code gen. But, for example, here's some of the stuff. If you're curious, I have a longer video linked down below in my stream description, but I can give you a brief... So, for example, here's something that I can do with my metaprogramming. So, say I want to have a struct, right? If I create a struct that's like, or no, how about a function, right? If I have a function that's like test function, and I want, all this is going to do is print out whatever you pass it, right? So if this was like some struct I have, it's going to print it out. This function can only take this one type of struct, right? It would be nice if I had a way to generate this for any struct in my program. So as part of my metaprogramming system here, I can pass this type, instead of giving it a specific type, I can just pass it this thing that I call any. And what that'll do is there's a step when I first compile my program. You can see the first thing it does is it runs this metaprogram. So if I run compile, the first thing it does is run the metaprogram, and then it compiles the main program. Well, what this metaprogram does is it can look at my whole syntax tree for my entire program, and the way I have it set up is that AST, that syntax tree, is passed to, it's at the bottom here actually, is passed here in this C file. So here's the default metaprogram, and you can manipulate it just through C code. So here is the AST of my whole program. This is passed. Yeah, exactly. We can write logic over our own code base, and because this is the tree that represents my code, it's just a tree data structure with nodes. You can do whatever you want. You can query, you can loop over it, you can do whatever you want, and then at the end of the day, that gets turned into this final.cpp file. Yes, it gets turned into this final CPP file. This is ultimately what gets compiled in my system. This is being generated from that AST. So for example, right now, one of the biggest things I do is I actually do generate 2 string functions and print functions for every struct in my whole program, which means anytime I create a new struct, I can automatically print it out and it's recursive. So if there are substructs inside of it, it'll just print out any data tab I have in my whole program. I'll never have to write a print function ever again, for example. And then there's other things that are more fancy that you can start doing. So one of the things I did is I replaced macros with these snippets, and they're a little bit fancier in that a macro is just like textual replacement in the program, right? It just looks for text and just literally like copy pastes over it. My snippets are, here's the snippet on the tree, right? Here's one that takes 2 parameters, and then it has a body. In this case, it's just a function call. So it's this one, 2 parameters and a body, which is just a function call. My snippets, what they do, it doesn't just do a textual replacement. It parses this as code, so you can see it parses it into a node on the tree. And then the body here, wherever I called it, which was down here, it will literally copy this node of the tree and stick it in there after it parses it. So it's like macros that are parsed code that then gets stuck into the tree. And the metaprogram is doing that as well. For example. Yeah. So my eventual goal is to take this and actually, like, I'm going to write platform layers for all the different operating systems, and like I do game dev normally. That's what my kind of normal programming is. But this new project I started just wanting to do some metaprogramming, so I wrote a C parser, but that quickly ballooned into me adding a bunch of my own language concepts. So it is ballooned into that. My eventual goal is to have a cross-platform library powered by the metaprogramming to eventually make games, more games, and do like just other any software I make, I'll use it as like the base for all that stuff. But so right now I'm the thing right now is these snippets. I only recently added the ability to do concatenation, since macros can do that in C. My snippets, that was something that I didn't have functionality for, so I still relied on macros. So that's what I'm doing right now, is I'm getting concatenation to work. So you can just stick these concats in and it'll textually replace that in the identifiers. You are a web dev, you're learning Rust to write distributed systems. I want to learn systems programming. I love doing this kind of low-level systems programming. It's why I like C. So it's exciting. It's, to me personally, it's very rewarding to do systems programming. That's also my day job, is I work on FreeBSD, like kernel and driver level stuff as my day job. I definitely love that kind of stuff, so good luck on that journey. It will be fun. I don't know much Rust, but I do know that, very similar to C, it can be very close to the metal, and it's good for that kind of programming. So C is good, but I was using GC, I assume you mean garbage collection, so long that I have to restart C language learning. Yeah, so that's another thing I'm not using and won't be using in this library. So the library I'm eventually building, relearning programming with memory management in mind. Yeah, exactly. So even the parser, it's technically written in C++, but it's basically C. The only things I'm using from C++ are, occasionally I'll use constructors and destructors for very specific things, and like operator overloading for like math. I think it's really useful to be able to just define your own operators. So, and actually the way I do memory is, even in the parser I do it this way. It's very similar to games. I don't know if you know what a memory arena is. Have you heard the term arena before? It's basically just like you allocate a big chunk of memory and you call it an arena. The arena has a base pointer, a size for how much you've used in it, and a total size for the whole arena. And so the idea is, at program startup, I just allocate a bunch of arenas on the heap. So I just get a big chunk of memory. And then on my own, I no longer touch the allocator anymore. I divvy up that memory myself. So the only allocation I do is right up front. And in fact, you can see it if I go to the parser here. push. Where do I do that? Arena. Oh no, that's in here. So see, I allocate up front. I say my input arena, output arena, and my scratch arena. I just give it some sizes, and in my whole parser, these three are the only memory allocations I do. It's these three memory maps. That's it. And then once I have the arenas allocated, I divvy them up and use them as I want. What are the programs I can write to learn systems programming, and do I use multi-threading? I think games are... If you're interested in video games, I think writing your own game engine is a great place to do systems programming. It's immediate feedback. If you're already into games, it's like fun to do that as well. That's how I learned it personally. And other than that, like, I guess it just depends on what you're interested in doing. And as for multi-threading, none of my stuff is multi-threaded right now, but I have done it in the past. And whenever I go write my my library for doing stuff, I will write a multi-threading system so you can easily like kick off jobs and stuff. So none of the parser uses multi-threading or anything, and it probably won't because it doesn't need to be that fast. I don't have that much time actually. I'm trying to make time for distributed systems, which requires strong systems programming. Yeah, where I can learn how a multi-threaded system should work. So a lot of where I learn stuff is this is again in the context of video games, but I followed a series called Handmade Hero, where he was writing a game engine from scratch, but he goes over very fundamental things like how do you do things in a multi-threaded manner? How do you write a job system where you can delegate tasks and have your multi-threaded system pick it up? Right, yeah, there's over 100 videos or 1,000 videos, but individual concepts, you can find like in fact, he might even break it up into playlists on his channel. There might be a specific playlist of like maybe a dozen videos that are specifically about this specific thing, like multi-threading, or here's a specific thing about memory management. Unfortunately, I don't really have any book or blog recommendations. I've been doing programming. A lot of it was self-taught on my end, and then I found Handmade Hero. So a lot of it is just stuff I've picked up over time. Unfortunately, so I can't give any more really recommendations, but yeah. Okay, cool. So you know. Okay, I guess I should have asked that up front if you were aware of the Handmade community and stuff. You guys, this is for Coder, obviously. So clearly you're aware of that stuff. Yeah, and my initial... So one of my long-term goals as well is... So this language, this like pseudo-language I'm building here. This like pseudo... What started as a C parser and now is kind of my own language. One of the things I did is because I have control over the whole syntax tree, I actually do a dependency map on the tree, and before I spit out the code on the final end here, it's all dependency mapped in the tree, so it spits it out in the right order to where the code over here can be order independent. There's no, this has to come before this before you use it. Like, it's all order independent. So one of my long-term goals is to write an editor myself for this language that doesn't even really have the concept of like files necessarily. It's all just like chunks of code, because the order doesn't matter as long as you know where stuff is. I kind of want to play around with that, so that's one of my like longer-term goals. I'm a ways off from that though, but it's definitely one of the things I want to explore. So so right now I gotta see why this thing does not have a line number, and I don't know why. how he manages this text that loads into the memory. So, from what I understand, is he also follows the kind of arena mindset. I think he does everything via arenas as well. But I think his arenas probably grow dynamically, similar to like a vector, if you know vectors in C. But yeah, I think a lot of it just comes down to not going through a lot of the typical like recommended best practices when it comes to programming. I think if you just do like the simplest things to start, oh, absolutely, arena is a real strategy. Yeah, absolutely. You might not see it in typical like academic or like corporate, just like general best practices. You don't really see it around that much. But for seriously like industrial programming, like especially like the biggest game engines that run like just really big feats of engineering like that, arenas are still a really big deal because they take out all the individual allocating, which is honestly one of the most expensive parts, is just getting a hold of the memory. Messing with the memory is pretty fast. So as long as you get it up front and mess with it how you want to, you can get a lot of speed out of that. I want to write my database. Like, would you want to write your like own database kind of from scratch? Oh yeah, absolutely. Like, I know a lot of people from that community like to like rag on like web dev and stuff like that, which I get it, but like it's not like that stuff is super easy either. But as someone who likes systems programming, it definitely feels like I'm doing more things, but I don't know, to each their own, you know. I definitely like feeling like I'm really close to the metal and I can like manhandle the memory and stuff, which a lot of programmers these days just don't do. They don't approach that stuff. Okay. So here I just have to give this the same line number. I just wasn't copying the line number over. Yeah, since I work in backend systems, I want write databases, parsers, servers, cloud tools, Linux tools. Well, that's really exciting because a lot of that stuff is stuff I don't do, but it's the same vibe, like the same area of programming, I think, in terms of just like deep to the metal systems programming. This was my experience day-to-day job in the job, but I consume them. I want to write my own implementations. Yeah. I'm the same way. I like to know how things work, and if I have an opportunity to do it myself, that's exciting to me. So that's cool that you have those ambitions, and I definitely wish you luck. I'm sure you don't need me to tell you this, but yeah, it just takes time and effort. Like, so honestly, I've been kind of a recluse for most of this stuff. My plan in the near future, that's why I started streaming my progress here. I do plan to start writing, do more long form writing, more like dedicated videos. I'm going to keep streaming. So, I don't currently write blogs, but that is in my plan in the short term future. So if you're interested, definitely give me a follow, and that would be cool. But yeah, I definitely have plans because I've also started consuming more or want to consume more writing. So, oh right, wait, I think okay. Now that you mentioned it, I think I actually recognize your name now. It's actually been like a month since I've streamed last, and yeah, okay, I do remember now. Sorry, my bad. It's been a I took a long break from streaming despite starting. You know, it happens. Line. Okay, I think I just didn't copy the line number over. Yeah, okay. That works now. Yeah, I would definitely start... I do want to start writing. I'm probably going to write to... I do have a personal website that is old, and I want to update entirely and start writing to. And I'll probably also start writing those same posts to Substack. And I also have a goal of, like, just for my own education and just as a project, I also want to write to... oh, what's it called? I'm blanking now. Gemini, Project Gemini, which is like, if you don't know what that is, but it's like it's a different web protocol that is pretty much entirely text-based, and there's a lot of like little communities in there, including like tech blogs and stuff that I want to start writing more and cross-posting to all these different places. So one thing at a time. I'll get there eventually. Okay, I fixed the line number thing, so that's great. Let's go back to why this isn't working. Oh. Wrong thing. Okay. So I'm not replacing the... Okay, so when I copy replace snippet calls in here, am I just not... Yeah, this is the part that's doing that. Update snippet copy decl. Okay, let's just see what we're not doing here. Okay, well, we're calling create node copy, which already gives me some pause because we just went and updated that whole thing. What are we copying here? Snippet source. It's a snippet called testing 3. Great. Okay. So let's see what our copy looks like. Line 45. Its parent is a source file. It has 2 parameters and a compound statement. It's called testing 3. Okay. Its parameters are okay, that's fine. Compound statement has a function call. Okay, so it looks like it copied correctly. Do concatenation we know works. This, I think, is the thing that's broken. So... why it's broken, I don't know. Let's figure that out. For each child node of the copy, so here we are. If it's a decl ref... Oh, wait a minute. For each child node, that won't descend into children, will it? Or do I do that recursively? I do that recursively, okay. So it won't be any of these. Recursively, go into it. That's a parameter. Okay, let's do this. Child is a parameter. Here, compound statement. Go into it. This is a function call. Go into that. Okay. So this one is a decl ref because we're in the function call. This decl ref is standard out file number. Aha. We're using the decl name still. That's no longer correct. In fact, let's get rid of that entirely. Decl name, because we should be officially done with that now. So decl name. Oh boy, we're doing that in a lot of places. No, we're not. Yeah, we kind of are. Okay, let's not get rid of it yet. But let's go to update snippet copy decl refs. We're gonna say instead of decl name here, we're gonna say just name, or yeah, decl name, and short string decl name is construct node name for child. Yeah. Okay, I have a big to do in here. Don't know what that's about. Let's just see what that does first. Okay, we failed. Corresponding param. So we're failing here. So let's see now. Here. Decl name is that. That's fine. This one is text. Okay. Snippet param ID is 0, which is actually correct. We did match it correctly. So this is no longer +1. That should just be the name. Holy work. Wait. Do we? Standard out file number. Yeah, we do. Oh, the 14 is wrong. Duh. This is now, we added, right. This is now 1, 2, we added 2 more. Dude, okay, that worked. That's all it was. Okay. We didn't update this to use the new identifier constructing thing, so that works. Great. Does 2 work? Yes. Okay, great. These all work now. Well, this doesn't because that is not right. Great. Okay. That's awesome. Cool. So, remove that. We're good there. All these cases work. That is fantastic. Let's see. The oldest to-dos here, are these even still relevant? So, update function properly, user, blah, 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 blah. Okay, this is not relevant. That's not relevant. This isn't relevant. Update function call if snippet. Good there. So does this work now? Do we even have a testing? Is that even a thing? No. Good. Okay, great. So now, let's say to do for next time. Today is the... Oh, crap, it's past midnight. I'm going to just say for yesterday then. 9/19/2025. We are back all of our snippets above work properly again. How exciting. Next on the table is to start start updating the other node types to use the new identifier system. This requires multiple things, and probably more I'm forgetting. So we're gonna say it's gonna take remove the old name string from every type to fully remove old references. Remove refs to old system. That can come later. We want to update all the other node types and the systems governing them to the new identifier system. Remove the old name strings from every type. Great. And then we also have to triple verify that the concatenation system works properly throughout the other types, which I think should mostly work automatically, which I think mostly should with little effort, since a lot of dispatching functions handle the grabbing of the identifiers. Okay, those are the major things. And dude, once this part works, I am like, I think ready to like call it done on this metaprogramming, on working on the parser. Well, I still have like a lot of these to-dos here, but these to-dos aren't new features. This is a new feature that I'm still working on. These are just bugs that I want to fix, but this is like the last feature that I think I need to work on, and then I'm ready to actually start using this, which I'm very excited about. But yeah, so there's still some stuff to do that are broken, but yeah. Cool. Let's push that up. Let's close this. I'm gonna go ahead and say thanks for watching, and yeah, thanks for hanging out, Chandru. I'm excited to hear about any progress you make on what you're learning as you continue to go through it. It's always exciting to go down new paths like that, and I definitely want to hear about it. We're back. Concatenation on calls and decl refs work. Concatenation on function calls and decl refs seem to work. Much more to do for other types. Great. Okay, well, thanks for watching, everybody. I will try to be streaming tomorrow and Sunday as well, like every day this weekend. I need to start getting back in the habit of streaming every weekend. So thanks for watching. Have a good night, have a good day, whatever time it is for you. And yeah, I will catch you next time.